Does anybody have any more questions about the homework? Yes. 7. So did you notice that I fixed the homework? That one weird typo. I don't know what. Which is funny because some people have already submitted their homework, which made me think, what did they do to that problem? Did they make anything up? You never know. True legends of calculus, as you are. All right, so what was number 7? Let me pull it up. I think, I better not just guess because that ends badly when you guess. No, it went down. Oh my Lord. So number 7, compute the area of a certain region. All right, so here's what we have. So this is number 7 on homework 1. So we have y equals negative x, y equals x squared plus 2, the line x equals 0, and the line x equals 2. So what region are we working with here? So once again, you're not hola. I lost my train of thought. What was I? Okay, so you're given 2 curves, you're given 2 lines. One of the things you have to remember is context. If I write x equals 0, that can mean the number x equals 0, or it can mean the vertical line x equals 0. So context is very important. So what you got to do is you got to say, okay, what's this region look like? Now you have some options. You can go to Desmos and check it out, but I would caution that unless you must, because these are pretty straightforward guys. So the first thing we ask is do we have a region here? Is the first question. So maybe I'll phrase it like this. So what is the region? We are working with? So what I would encourage that you do is I would encourage that you sketch these things. So, and I always think it's good practice to try to sketch without looking at technology. That's just my opinion. You know, oftentimes simple things can be sketched quicker than it takes for you to open up your computer, type Desmos into Google or whatever. I know you're going to disagree with that, but it's true. So what do we have? We have the line y equals negative x, so I'll draw that in blue. So that creature is going to look like this. Okay, so what is this particular? This is the line y equals negative x. Now, the other curve is this curve, what is it, x squared plus 2? Yeah, y equals x squared plus 2, which is a parabola. Do that in red, and it's shifted up 2. So the question is, how is it shifted up? Where does it intersect this blue line, if it does? Right, so let's go to that. Before we draw it, let's ask ourselves, what's the intersection point? Points. I don't even know if it has any, but I got to try to find it. So how do I find it? Well, I'm going to set x squared plus 2 equal to negative x, correct? And of course, when I go to solve that, that's the same as x squared plus x plus 2 equals 0. And then the question becomes now, what are the solutions to this? This thing doesn't look to me like it factors, obviously. So I'll use, say I use the quadratic formula, x equals -1 plus, you might not have this memorized anymore, it's fine. Then this will be 1 minus 4 times a, which is 1, times c, which is 2, all over 2a, which is just 2. But what you notice right away is that this is bad news, right? So there are no real solutions. Correct? All right. So what does this mean? This means thus y equals -x and y equals x squared plus 2 never intersect. Does that make sense? So what we know then is if we go draw the graph is going to look, as we might have sort of concluded, it's going to look something like this. So this is y equals x squared plus 2. Okay, so what are the other lines now? The other lines we wanted were x equals 0. So I'll draw that in purple. And then the other line was x equals what? 1, correct? Is that what it was? Am I reading the wrong thing? X equals 2. No, I have x equals 1. Number 7. You're talking problem number 7. The lines are x equals 0 and x equals 1. Wait, what? Oh, I did in the previous page. Oh my God, I'm a numbskull. This should be 1, right? Thank you. That doesn't change anything. Thank you for pointing out. So I had a typo in the original problem. This should be 1. On the homework, it's 1. So make sure everybody gets that this is 1, not 2. Sorry about that. Thank you. See, I'm looking at you like you're crazy, and I wrote the darn thing wrong. Okay, so if I get this line out, then I can sketch this. So what's this look like? Well, let's just say it's right here. And how do we know what these points are? Well, what are these points? Well, we can easily get them just by plugging in chugging. So, but it's unnecessary. We don't even need them. I mean, this is the point if you want 2, -2. And this is the point, plug in 2, or excuse me, why am I putting 2 in? It's 1, right? Good gravy. I should be fired. Sorry, guys. It's Friday. This is 1, -1, if you will. So this is definitely not to scale, but oh well. And then this is 1, 3. So the region we're after is this one that I'm going to shade in. And so since the top is the parabola and the bottom is the line, the area of the desired region is the integral from 0 to 1 of x squared plus 2 minus -x dx. That's it. Which in this particular problem becomes integral 0, 1 of x squared plus x plus 2 . And so this one is a pretty straightforward guy. You get 1/3 x plus 1/2, excuse me, 1/3 x cubed plus 1/2 x squared plus 2x evaluated from 0 to 1. So that's 1/3 plus 1/2 plus 2 minus 0 plus 0 plus 0. And then if you just do your arithmetic, 1/3 plus 1/2 is 5/6. And 2 is 12/6. So if we didn't make any errors, we get 17/6. So think about that if you have a question or anything like that. Yeah. Well, on this problem. Okay, hold on 1 second then, and we'll get to that. But does anybody have a question on this before we move on? Going once, going twice. So Josh wants to do number 10, and then we'll come back to you. Let me see what number 10 is. I'm hitting the wrong key. All right, so number 10 is going to be very similar to one of the ones we did yesterday. It has a duplicate. It has two regions. You have to consider them separately. So again, let's look at number 10. So again, I'm going to sketch this region, and here's my x-axis, here's my y-axis. Here's y equals x. So this is the line y equals x. I'll get red out. X to the 5th looks pretty much like x cubed. It's just a little steeper. So if we sketch that, it comes up like this, flattens out, and then curves up like this. So this is the curve y equals x to the 5th. So the region that I'm interested in is, there's two of them. I have this little petal here. And then I have this little petal here. Now, a shortcut in this particular problem, if you take advantage of some intuition, you can use symmetry to cut your work in half. Does that make sense? Both of those petals are the same size, right? Does that make sense? So what I'm saying is the area is equal to the integral from, the only thing you have to do is where do they intersect? Well, they intersect at -1, 0. So the area becomes the sum of these two integrals. But these things, using symmetry, you can use symmetry here. This is the same thing as 2 times, pick one of them. I'll pick this one. Now again, if you're not sure what I mean by that, you can do both, but that's just double the work. So let me make sure. I'm going to write that over here. Is anybody unsure of why I can do that? Okay, so then this is just another straightforward integral. This is 2. Then you have x squared over 2 minus x to the 6th over 6 from 0 to 1. And you plug in 1. You get 2 times 1/2 minus 1/6 minus 2 times 0 minus 0. I'm putting the details in to help you guys out. So you end up getting 1/2 minus 1/6. Well, 1/2 is the same thing as 3/6. So you get 2/6, which is 1/3. So this simplifies to 2/3. Does anybody have a question about this? Comment? I have to stretch my legs. Comments, questions? Does this make sense? You're very Pittsburgh today. You got the Pirates, the Penguins. You need Steelers shorts on or something. No, not a Steeler fan? That's rare. Do you watch baseball games? Did you watch the game last night? The rough one. We flipped on back and forth between that and the basketball game. All right. Does anybody have any questions about this problem? No? All right, so that's number 10. Which question did you have? 6? Okay. Well, yeah, you get so 6. I'll help you set it up. 6 is an interesting one. So the question was number 6 over here. So this one's tough if you don't. So you might not be able to sketch this one by hand. You might need to go to a calculator for help. So this one you might, or let me not say might, you likely need help from Desmos here. And you're going to have, so this is one of those ones, so we'll go to Desmos. Let's see if I can, so hopefully if you're seeing Desmos, let me know if you don't see Desmos. Let's graph this. So you have y equals e to the x. Now the problem with y equals e to the x is it gets steep real quick, right? And then you have y equals, if you just plug it in, 2x plus 1, you might say, okay, that's the only region there is. But there's actually not. There's going to be another piece to this. So the only way you're going to really see it is if you kind of readjust your graphing. Does that make sense? However, though, look at the lines I told you to use. I said x equals 0 and x equals 2. So let's graph x equals 2 as well, and you'll notice that it's right there. So the region that you're considering, and this problem is tricky. So when you graph this, you say, okay, I see the first region is top blue, bottom red. And then in the second region, it alternates. Does everybody understand that? So the difficulty, though, in this problem is a different difficulty than we've had before, because now here we got to find this point. So this is a subtlety. So how do we handle this? Well, here's what we know. So again, let's go back to the whiteboard. So note, let's sketch the region. Even though we got a little assistance from the internet, I'm gonna put this line here, and I'm gonna put. So the region that we have is that, and then we have this 2x plus 1. So we have this line. Let me remember what color that was. So the line was blue. Okay, good. So 2x plus 1 looks, let's say it's like, oh, that's not good. It has to be up a height of 1. So 2x plus 1 looks like this. Then my exponential, they intersect at 0, so that's good. My exponential comes like this. It's underneath. Then it goes up, right? And then I have this line at x equals 2, correct? So again, we're sketching the region. This is not. So this is x equals 2. So we have two regions now. we have this pink guy right here. And then the other part of this region that we're interested in is this. I'll use, guess I'll use yellow. So does anybody have a question about this? Okay, so now the observation is, how do I know what this point is? So here, it's not at all obvious what this point is where they intersect. I know what the lower bound of my first integral is, it's 0. I know the upper bound of my second integral, that's going to be 2. What I don't know is where they change over. So where do they intersect? Well, we have to solve. We need to know, when is e to the x equal to 2x plus 1? Well, this guy can't be solved using techniques from algebra class. You can't move things to the other side. You can't use some quadratic formula. There's no way for you to manipulate symbols and solve this equation. Is everybody understanding that? So then the question is, what do you do? Well, one option is to learn how to solve that. Maybe you might recall we learned something in Calc 1 called Newton's method. But all that does is give you an approximation. So one option is to use an approximation. So one idea, I'm not saying this is the best way to do it. Maybe you can be creative and come up with something else. So one idea is to use a calculator to approximate So we already did that because we graphed it. So when we graphed it, if I go back to Desmos, we saw that it intersects at the point 1.256, right? So let's use that point. Oh. So therefore, we no longer have an exact answer. We only get an approximate area. Now, it turns out that it's pretty good approximation. So what is our area gonna, not error, area. Oh, Grady. So our area is the integral from 0 to 1.256 of, what was the upper bound here? The upper bound was the line, so this would be x, 2x plus 1 minus e to the x. And then it would be plus the integral from 1.256 up to 2 of e to the x minus 2x plus 1. And then you guys can, I'll let you guys finish from here. But this is a good example of how we cannot get an exact answer. The best we can do is approximate. Does that make sense? Now, of course, as we know in the real world, approximation is fine for many things. It just depends on how accurate do we need to be. Now, that being said, anytime we can get an exact answer, we want an exact answer. Does everybody understand this problem? So I like this problem because it reminds you, hopefully as students, that not everything is the same. You can't just because one problem is a simple procedure doesn't mean they're all that way. Does anybody have a question? Any other questions on this homework? Everybody's good? Going once. Okay, so we have a few more minutes. Then let's sort of motivate the next topic, which is volume. So given a solid defined and determine its size. So the English word for sort of size in the plane is area. Right, think about it. In dimension one, in one dimension, we think of size being length, the length of a line or something. In dimension two, in the plane, it's called area. And then in three dimensions, like in space, like where we live, things are called, the size is typically called its volume. And so the idea is very similar to what we did with area. You take the object you want to study and you break it into small pieces and study those pieces. Approximate them with something that is known. Does that make sense? And then once you approximate them, you add them all up. And the beauty is, because we have this awesome thing called the limit, when we add them all up, this sum becomes, in many cases, an integral. So that's exactly what we want to do. So to do this, we follow a familiar formula. Take what we want to study, slice it up into small pieces, approximate these pieces with known things, whatever that might be, and then add them up and get an integral. That's the game. So this is a formula that we're going to use a lot. You guys, many of you will use this in other classes, particularly in physics or maybe in a physical chemistry course or something like that. You want to understand something, you chop it up into small pieces, study one of those pieces, figure something out about it. In this case, if we want to know the size of something, we could take an object, slice it into small pieces, compare one of those small pieces with something we already understand size, get a formula for it, add them all together, and you get an integral. Okay, so what we need to do is we need to start by defining two shapes or two solids and their volume. So actually, let's be more cute. Let's, instead of saying two, let's do three. Oh no, I guess we could just leave it at two. The other one's a special case. All right, so let's just take, what is one of the simplest shapes you can think of that's a solid? A cube, right? But we don't want to just study a cube. We want to think of anything. So what is it called when you have, you know, a cube is when all sides are the same, but what do we call it when not all sides are the same? A block, a box, what do you call it? What do you want to call it? What's that? A rectangular prism? Is that what you said? Yeah, that's one word. Let's see what Google says. What is a rectangle in 3D called? I like this. I love how Google already knows what I'm going to ask. That's what they call it, a rectangular prism, or cuboid. Or the other fancy word is, what is it? A parallel pipet, right? Those are fancy words. Let's just call it a box. So what I'm going to call this is, I'm going to call it a rectangular box. So, I mean, this is, let's, you know, as this face, we'll try to give it some perspective. Oh, that's bad. That there is a junk box. And so we can try to add some perspective to it. If we give it some dimensions here, you know, you might say, okay, this has a length, it has a width, and it has a height. And so what is its volume? Its volume is L times W times H. That seems very reasonable. It's a very natural way of defining it. It's completely analogous to taking a rectangle, right? And think about it. Think about how you might build a box. You ever see a ream of paper before? You know, like your printing paper, a ream of it. I mean, think about that. If you think about every one of those like sheets of paper as a rectangle, and then you put them together, it creates depth to it, right? And so you can imagine, how would we think the size of that ream of paper? Well, it's the length and width of one sheet of paper times how many there are, right? That's the thickness of it. Okay, so that's our one shape. And then our other shape, we're going to call it, I'm going to call it a disc. And so what does this disc look like? This disc is going to look like, you have like the penguins on your face mask, right? So maybe like a hockey puck. You could think of it as a penny or a hockey puck. So what might that look like? It's going to look something, let's put it on its side. So you imagine that it sort of looks like this. And so what are the dimensions of this thing? I mean, you could think of it as a cylinder on its side, right? What are the dimensions here? Well, there has to be some distance from the center here. That's the radius. Then there has to be some thickness, which we can, I don't know, let's call it, for the sake of argument, let's call it H again, I don't know. And so what's the volume here? The volume of this, we are going to define it as pi times the radius squared, because that's the area of a circle, and then times its thickness, which is its height here, if you want to say it that way. So I'm pointing this out. We're making this definition. Now, these are completely natural definitions. We can assign size to these things any way we want. We could say the volume of that box is cat, but that doesn't help us with anything. Right? And you will also notice that these definitions would agree if you shrink them down and try to shrink them to 2 dimensions, they agree with their 2-dimensional counterpart. Right? Take that box. And imagine you'd have a box of height h, and you just keep h getting smaller and closer to 0, right? So when h is a very, very small number, then you would expect the volume to be what? It's actually a very good mind game. Play with yourself. Think about that. Okay, here's a simpler way. Think about h being 1, for example. When h is 1, what do you have? You just have length times width, right? Anyhow, these are, you can imagine these are very, they're intuitive, I think, right? You know, think ream of paper, if you will. Okay, okay, good. So what we're going to do then is we want to say, okay, given a solid, can we chop it up into 1 or 2 of these things? So given an arbitrary solid, can we slice it up and approximate slices with a box or a disc? And of course, the answer is not all the time, but often yes. So we'll just give 2 examples. We're not going to do them yet, but we'll show you 2 shapes, and then we'll talk about that in general on Tuesday. Does anybody have a question, comment? This is fun. Fun times are had when you do math. So let's take a pyramid. So, you know, they should have these built in, but they don't. Damn it. Take a pyramid with a square base. I'll try to draw this. That's my 3-dimension, but let's try to take a slice of this. If I slice it like horizontally like this, So it's not technically a box, but we can approximate it by it, right? Does that make sense? Another way to think of that is if I took my pyramid and I set it on the ground and I stood up above it and I looked down on it, it's going to look like what? A square from that perspective. Does that make sense? Or if I turned it on its side and looked at it from the one angle, it's just going to look like a square. If I slice this thing horizontally, the slice is a box. All right, now let's take some other shape. Maybe I have some weird thing. It looks like this. Maybe like I take a vase. You ever have a vase with flowers in it and stuff? Maybe this is some sort of vase. I don't know. A vase, as they say. And so if I slice this creature up, maybe I take a knife and I slice it vertically. I guess I shouldn't put that like that. This has to be dotted. So this slice is almost a disc. So maybe I should be clear. I should be even more clear. This technically isn't a box, but it's almost one, whatever that means. I mean, it's not perfectly perpendicular, but we can approximate it by one. Does that make sense? Anybody? I don't know. And this is a process we're going to do for other things too, not just volumes. It's going to be useful for finding pressures and forces. Like imagine water against a dam or on the bottom of a pool. Imagine trying to compute the work done. Maybe some of you are familiar with the word work from physics or something. All right, does anybody else have a question? Because it's time to go. The authorities say we have 45 minutes under the corona social distancing, whatever it is, and that's it. This party has ended. It is Friday. Go home and I'll give you some problems to think about, and we'll talk more about this on Tuesday. So have a good weekend. Yes, question? Yeah, so the quiz thing, I'm going to put, that's a good question. As I said, there's going to be weekly quizzes. You should not think of these as hard things. I am going to, what I'm going to do is I'm going to put something on Canvas. It'll be open for a few days. I'll put it sometime today or tomorrow. You'll have to like Monday or Tuesday. Maybe it'll take you 15, 20 minutes, half an hour, probably not. But it'll just be a couple questions. It's 5 points. What did we do this week? Maybe a multiple choice question or something like that. It's meant to be easy, so try to get them correct. All right? It's not meant to be hard. It's not like a quiz in the sense I'm trying to punish you. I'm just trying to keep you thinking about calculus. That's all. All right, any other questions? No, it won't even be like that. The quiz will be like on Canvas. You'll just answer questions or type in the Canvas. So it'll grade it automatically. Yeah. Does that make sense? Yeah. So the question was, will it be, you won't hand it in. It'll probably be like a couple multiple choice questions or a fill in the blank or tell me what we did, or maybe you type a couple sentences or something. It won't take long. It's not meant to be stressful or high stakes. It's meant to be simple. All right. Have a good weekend, everybody. Stay safe. I will talk to you on Tuesday, if not sooner. Bye now. Thank you.